Let's bang out geometry constructions. All right, so let's say, first of all, we want to do an angle bisector. All right, that's our first construction. What is an angle bisector? Let's say if we have an angle that's 40 degrees, the angle bisector will split the angle into two equal smaller parts. All right, so it's going to split it up into 20, 20. All right, splits it up into two equal parts. Now we have the angle, and you want to place the compass. All right, this part of the compass on the tip. All right, this tip of the compass on the vertex of the angle. Okay, and in geometry regions, you're gonna get a weird looking compass that's not looking like this. It doesn't look like this, and I'd recommend bringing in your own compass. All right, it's much easier. What we're gonna do, you're gonna create an arc. Okay, just gonna create an arc. And when you create an arc, right, it's going to have two intersection points, right? It's going to intersect this part of the angle and the other part of the angle, right? And you want to place the compass right here and make another arc, okay? And to keep it simple, all right, I'll do the same length as I did for this arc. You can see how this lock thingy means that the compass is the same length as before, all right? It's the same length. So I'll just make an arc the same length on this, and then I'll make an arc the same length on the other. All right, putting the compass on the other intersection point, I'm going to make another arc. And you can see how this arc, right, these two arcs I just drawn have an intersection point right here. And I'm going to draw a line through this intersection point, and that's going to be our angle bisector. All right, now why does this work? Well, it's because, right, we can make two triangles, okay? We can make two triangles. And you'll see how we use the same length for this arc, right? Remember for, if I just drag my pencil up here, we used the same length for, why is this thing like this? Come here, come here. All right. We used the same length for this arc right here. So right over here, we use the same length for this arc. So these two segments are congruent. We use the same length for this arc, right? This arc, we use the same length, right? This is the same length as this, right? So these two segments are congruent. They're the same length. And they share a common side. So you can see how they're congruent by SSS. Are these two triangles are congruent, meaning that their corresponding angles are going to be congruent. So this is why this works. And second one we're going to be doing is a congruent angle. Okay. So I want to construct the angle that has the same measure. All right. For example, if this angle measures 40 degrees, I want another angle that's 40 degrees. So how would I do that? How would I do this? Well, first you have to have your first angle, and you have to have, all right, you have first angle here, and then let's just say you have part of your second angle. All right, you have just a line. We're gonna do, take your compass here, gonna draw arc once again, and take the compass and the vertex of, so at the end of your second, right, segment, right, and you're gonna make an arc. Now what we're gonna do is you're gonna place the compass on this intersection point. All right, in this case we're going to place it on the bottom intersection point. All right, right here. And what you're going to do is you're going to draw, all right, sorry, all right, you're going to place the compass on this intersection point, and you're going to put the tip of a pencil on the other intersection point. So this intersection point right here, this one right here. And we're going to do, what you're going to do is you're going to draw an arc like this. All right. And for this one, right, you set it to the same distance, right? You see how the lock is on. So you're going to set the compass to the same distance. you're going to place this on your first intersection point, and you're going to do another arc. And you can see how in the first angle, this arc intersects this line right here at the same point. And this arc, we can see, has another intersection point with the other arc I just drew. And what you're going to do is just going to draw a line through this intersection point. Okay? Just draw a line through the intersection point. And yeah, that's all. And once again, this works because you can form a triangle like this on both angles. We know that this distance right over here, so this distance right here is kept constant throughout the whole angle. So we know that this side is congruent to this side. We also know that remember this arc we've drawn here, right? This arc we've drawn here, I'm sorry, it's the other way. Right, this arc we've drawn here, right? This is the same distance as this arc we've drawn here, right, with the compass. So these two sides are congruent. And finally, right, because it has this same intersection point, right, you can see how the distance from this to there is the same as the distance from here to here. So these three sides are congruent. And once again, corresponding angles are congruent. So we just constructed a congruent angle right now. Let's say that we have a line, and we want to construct a line parallel to this line. So parallel lines, if you don't know, just lines that don't ever intersect. First thing you want to do, you want to create a transversal. All right, so just create a random line intersects through this line. Okay. What we're going to do is you're going to take the compass and you're going to put it at this intersection point. So this point right here, you're going to put it at the intersection point. And you're going to draw an arc. Okay. And you want to move this compass to another random point on this line. Let's just say this point. You're going to draw the same arc, all right? So the same distance arc. Okay. So right, same distance arc right here to right here. Same arc. Now what you want to do, right, you want to take your compass, you want to place it on this top point right over here. So this top intersection point, right, where the arc you've drawn intersects this transversal you've drawn, and you're going to create an arc like so. All right. And just to mention, the arc has to be a length from this point, so this one intersection point, to the other intersection point. All right, you want to put the compass to the length of that, and you want to draw arc. And you do the same thing here, right? This one has intersection point, and you just want to place it here. Keep it the same length as you did for this one, and you want to draw an arc. You can see how these two arcs, they have an intersection point. So you can draw a line through it, and boom, you've just drawn a parallel line to this one. Why does this work? All right. Well, you're basically constructing a congruent angle in this construction. Okay. So remember, if we construct a triangle, right? Whoa, what just happened? Okay. So if we construct a triangle like this, you can see this triangle and this triangle. And once again, these triangles are congruent, as, on all of the sides, right? All of the corresponding sides, we put the compass to the same length. So all these sides are going to be congruent to all these sides we've drawn. All right. Meaning that the angles right here are congruent to each other. And when a transversal intersects two lines, if corresponding angles are congruent, so if these angles are congruent where a transversal cuts through these two lines, then the lines are parallel. So yeah, because we just constructed two congruent angles through this transversal right here, we proved that these two lines are parallel to each other. Okay, let's construct an equilateral triangle. There's two ways to do this. All right, equilateral triangle is just a triangle that has the same length on all the sides. All right, so all of its sides have the same length. First way, so just do a random segment. Let's just say it's this length. You want to put your compass to this length. All right, you want to put the compass to the length of this line right here, line segment right here. Draw an arc. And now you want to place this compass right here, and you want to draw an arc the other way, okay? So in the first step, you put the compass here, you drew an arc this way, and then the second step, you just put the compass on the other side and drew the same distance arc. Drew the same distance arc right here. This isn't really clear, so I'm going to do it again. So yeah, place the compass here, put it to the distance of the line segment, draw an arc. Now you just want to swap positions, basically, and you want to create another arc right over here. You can see how these two arcs have an intersection point, so just connect all the lines, and boom, here's your equilateral triangle. Another way you can do it, you can have a circle, right? And sometimes, usually they give you a circle, and they'll ask you to make an equilateral triangle inside the circle. What you're going to do is you're going to place the pencil part on, you're going to place the pencil part on the center of the circle. You're going to place the other part on anywhere on the circle. You're going to drag the pencil a bit. Now you're going to drag the pencil a bit here, and you're just going to create an arc that intersects the one part of the circle. And you're just going to keep doing this, doing the same length, all right? Keep it the same length, and you just do another arc. You place the pencil down here, just do another arc. Now place the compass on the next intersection point, bring the pencil down, and do another arc. All right, you notice how I kept the compass the same length throughout the whole thing. All right, so I just bring the pencil down here, create another arc. Compass down here, intersection point, I create another arc. Down here, I create another arc. You see, and you'll see how all these, the distance between this intersection point and this intersection point is the same as the distance between this intersection point and this intersection point. And that's because we use the same distance every time. And for equilateral triangle, you want to take one of the intersection points, all right, and you're going to link it to the second kind of away from this intersection point. All right, so you see how this intersection point is one away from this intersection point, and you want to do it to every second intersection point. So what I mean by that is you're going to connect this one to the second one, and you connect this one to the second one away from it, and connect this one to the second away from it. So it's kind of like you skipped one of this. All right, connect this one, you skip this one, connect it here. Skip this one, connect it here. Skip this one, connect it here. And here's your equilateral triangle. And guess what? If they ask you for a hexagon, connect all the points. Connect all the points. If they ask you for a hexagon, boom. Pretty cool. All right. How to construct an perpendicular bisector. Let's say we have a line. Actually, let's make the line smaller. And a perpendicular bisector, it's basically a median. It's the same thing. It's basically a median plus an altitude. All right, that's basically a perpendicular bisector. All right, it's a segment. It cuts through a line, or in this case, a line segment. It cuts through this line segment right here. And what it does is this splits this segment into two equal parts. All right, so if this whole segment has a length of 10, it would split it up into a length of 5 and 5. All right, and what else it does? Well, it creates 90-degree angles. All right, so that's the definition of the perpendicular bisector. Creates right angles, and it bisects this segment right here. So how do you construct this? You're going to take your compass, you're going to place this tip of the compass at the edge of this line segment, and you're going to take the compass and you're going to put it at a distance that's greater than kind of 50% of the segment of the distance of your line segment. So what I mean by that is place it more than halfway through this segment, all right? And you want to create an arc like so. You actually want to create sort of like a semicircle, and you keep it the same length. You place the compass on the other part, the tip of the compass on the other part, and you want to create another sort of semicircle. And you can see these two parts have an intersection point, two intersection points. So just connect them. Boom. Here is your perpendicular bisector, and there's the right angles. And why does this work? Well, you can essentially sort of create a rhombus, right? You can create a rhombus from this because the distance from here to here is the same as the distance from here to here, right? This distance is congruent to this distance, as we kept the compass the same length throughout the whole entire thing. And this distance is congruent to this distance, remember, because we drew a semicircle, and this is going to have the same distance. So all these sides have the same distance from each other. All right, they have the same sides. All these sides are congruent, meaning that this is a rhombus. And the diagonals of a rhombus are perpendicular, so they create right angles. And yeah, that's why this works. Also bisects this other diagonal, which is why it works. What else? Let's say we want to construct an altitude, okay? So let's say we have a triangle and we want to create an altitude. So altitude is just a line from one vertex of the triangle, and it comes down to the opposite side, and what it does is it creates right angles. So we want to do this. So the first step, right, we have this side, and what you want to do is you want to set the compass, or you want to put the tip of the compass on this side, all right, on the side that you're creating the altitude from, on the vertex, I mean. Now you're going to place the pencil on the opposite side, right, the side the altitude is coming down from, and you're going to create an arc, all right. And you can see how this arc has two intersection points. And in these two intersection points, you're going to create a perpendicular bisector. So yeah, we just did that. And once again, we do place compass here on one of the intersection points. And you're going to go 50%, more than 50% of the way through this segment. You're going to create a semicircle. And then now you want to place the compass tip on the other intersection point. You want to create another semicircle. And boom, just draw a line from this vertex all the way down. And you'll notice how it's not perfect, but it sort of intersects. It goes through these two intersection points I've drawn. And yeah, that's going to be the altitude. All right, and we also have a median. So what is a median? All right, what is a median? Well, if we have a triangle right here, a median is just a line that goes from one vertex of the triangle to the opposite side and splits this opposite side into two equal parts. So how do we do this? Well, let's say we're trying to make a median from this point over here. Well, what you're going to do is you're going to create a perpendicular bisector on this segment down here. All right, you're trying to find the midpoint of this segment, and once you found the midpoint of this segment, just link it up. And yeah, so perpendicular bisector, go more than 50% of the way there, And what you're going to do is you're going to construct a semicircle and do the same for the other side. And link up the segments, link up the intersection points. Ooh, you have your midpoint now. You have the midpoint of these two lines. And the definition of a median is a line going from one side to the midpoint of the other side, right? Remember, it splits this segment up into two equal parts. So if this is a midpoint of this segment, it will split it up into two equal parts if we draw a line from here to here. All right. And finally, we have, let's say if we have a line and we have a point on the line. And let's say we want to construct a line that's perpendicular to this point on this line. All right. So we want to construct a perpendicular line given a point on the line. Take a compass, place the tip of the compass on this point, place the pencil on, set the compass to any length, place the pencil on, any side, draw arc, right? Doesn't matter the length, just draw arc. Arc, you'll see has two intersection points, right? And you'll see how the distance, right, because this is a semicircle, right, you'll see how this is a radius of the circle, and this is also a radius of a circle, right? These two sides are congruent. So imagine if we construct a perpendicular bisector down here, right? This will be our plane, okay? This is our plane. So, yeah, sorry, what happened to my arc? Let me just redraw that. So what you're going to do, place the compass on one of the intersection points, place it more than 50% of the way through the segment, and draw a semicircle. And do the same thing for the other side. And you can see it has two intersection points. So, boom. And draw a line through. Right angle, boom. Perpendicular bisector on a point that's on a line.